Imagine a packed sports bar on the opening Sunday of football season.
Yeah.
You've got this massive 160-panel digital video wall.
Oh, the energy in those places is insane.
Right. But then a tiny, completely invisible electrical spike hits the building's wiring, and instantly that entire video wall goes completely black.
Absolute nightmare scenario for any business owner.
Exactly. And today's custom-tailored deep dive is created specifically for you, the listener, to figure out how to prevent that exact disaster.
Yeah, it's a crucial topic.
We're digging into this massive catalog from HDTVSupply, which is a vendor with a 25-year global history in AV products.
You've seen it all.
They really have. And while they sell these incredible, massive setups, we are zeroing in on the unsung hero that keeps it all running safely, the SurgeX SX-DS-208 Defender MultiPak.
A very specific, very important piece of gear.
So, okay, let's unpack this. Why does high-end commercial equipment require advanced power filtration, and why will a standard power strip just not cut it?
Well, to understand why a standard strip fails, you have to look at the microscopic architecture of the gear we're actually talking about here.
Okay, lay it on me.
So in the HDTVSupply catalog, you have these massive 160 by 160 HDMI matrix switchers and incredibly complex commercial projectors.
Right.
And these devices, they don't just draw power, they rely on really delicate microprocessors and extremely precise timing protocols.
Just to route those ultra-high-definition signals across dozens of screens simultaneously, right?
Exactly. So building a massive multi-panel digital display network and plugging it into a standard $10 power strip
It's like buying a Ferrari and putting bicycle tires on it.
Yes. That is exactly what it's like, because protecting these displays isn't just about, avoiding a temporary blackout.
It's about the hardware.
Right. It's about preventing severe downtime that literally kills commercial operations.
So why are these specific electrical transients so dangerous to this level of gear? Like a minor voltage ripple that a commercial refrigerator wouldn't even register.
Yeah, that same ripple could completely scramble the logic board of an HDMI matrix.
Oh, just fry it completely.
Precisely. Because we aren't just worried about a massive lightning strike. We are dealing with everyday transient voltage spikes.
Which happen all the time.
All day long. In a commercial environment with HVAC systems kicking on, heavy kitchen equipment, constantly shifting grid loads, these microsurges are constant.
And if one of those hits the video wall matrix...
It doesn't just trip a breaker. It degrades or outright fries the delicate silicon pathways routing those digital signals.
Jeez. Okay, so if these HDMI switchers are intensely sensitive to minor voltage ripples, what is actually happening inside a standard surge protector that makes it such a massive liability?
It comes down to the core technology.
Yeah.
Conventional surge protectors rely on what's called a single-stage MOV.
Which stands for metal oxide varistor, right?
Right. And the fundamental flaw of an MOV is that it is a sacrificial component.
Sacrificial. Meaning what?
Well, it's designed to absorb excess voltage, but with every hit it takes, its chemical structure physically degrades.
Wait, really? So the surge protector I buy at the hardware store is literally designed to fail over time?
Yep, it's a consumable.
It's basically a sponge that eventually gets completely full, stops absorbing water, and suddenly all that excess water ruins the expensive table underneath it.
That's a perfect way to look at it.
Huh.
And the worst part is, it fails silently.
Oh, that's terrifying.
Right.
Yeah.
You often have no idea the MOV is dead until a surge bypasses it entirely and destroys your $50,000 video matrix. Relying on a degrading sponge is just an unacceptable risk for commercial operations.
Which brings us to the actual mechanics of the SurgeX Defender MultiPak.
Yes, the heavy hitter.
Looking at the physical specs, it provides 8 outlets with a highly robust 20-amp, 120-volt plug configuration. But here's where it gets really interesting.
Oh, yeah.
It abandons that sacrificial MOV technology entirely. So how is it actually stopping the surge if it's not using that sponge?
So instead of a sacrificial component, it uses what's known as multi-stage technology.
Okay, how does that work?
When a transient spike enters the SurgeX, it first hits a series of inductors. And these inductors act like an electromagnetic brake.
Just immediately clamping down on it.
Exactly, instantly slowing down the rapid rise of the current. Once the surge is slowed, industrial-grade capacitors catch that energy, absorb it safely, and slowly bleed it out into the neutral line.
So instead of a breakable shield that shatters a little bit with every hit, it operates more like a car's shock absorbers.
That's a great analogy, yeah.
It takes the kinetic energy of the bump, dissipates it smoothly, and resets without taking any permanent damage.
Exactly. It intercepts and diffuses the transient energy through magnetic and capacitive filtration.
Meaning no degrading chemicals.
Right. Because it doesn't rely on degrading chemical components, the filtration system doesn't lose its effectiveness over time, making it the premier choice for long-term fail-safe operations.
You absolutely need those shock absorbers to ensure the digital show actually goes on.
You really do. And, if we connect this to the bigger picture, true reliability in high-end AV environments requires power filtration that completely bypasses the inherent limitations of traditional single-stage MOV designs.
Makes total sense.
You simply cannot build a reliable, permanent commercial system on a foundation designed to silently break down.
No, you definitely can't. Which leaves us with a pretty compelling thought for you to ponder today on your own.
Oh, for sure.
If single-stage MOV circuitry is considered dangerously inadequate for a sports bar's video wall, how vulnerable are the expensive smart TVs, gaming consoles, and computers plugged into those exact same silently degrading power strips in our own homes right now?